Today in this lesson I will explain what is Grignard reagent and also I will explain reactivity with the help of few examples. First of all, what is Grignard reagent? Grignard reagent basically it is a derivative of alkyl halides, and it was first prepared by the scientist named Victor Grignard, and he prepared by using alkyl halide. Basically he reacted alkyl halide with the pieces of magnesium in the presence of dry ether. So what is dry ether? The ether which is free from alcohol. It should be alcohol free, it should be water free, you can say it should be pure ether. So when he reacted alkyl halide with magnesium pieces in the presence of dry ether, so he get the Grignard reagent, and normally the formula of the general formula of Grignard reagent is RMgX. Here R represent any hydrocarbon chain or any alkyl group, and Mg stand for magnesium with magnesium metal, and X can be any halogens, especially the most common halogens are chlorine, bromine and iodine. Okay, what is the importance of Grignard reagent? Why RMgX Grignard reagent is very important? Due to it forms carbon-carbon bonds, and it basically very important due to its ability to make so many organic synthesis. Because of this Grignard reagent, so many new organic compound can easily be formed in the laboratory. So that is the reason it is very important. Now let's discuss few reactions of Grignard reagent. Today in this lesson I will going to explain with mechanism the reactivity of Grignard reagent with formaldehyde, acetaldehyde, ketones, carbon dioxide and ester. When Grignard reagent RMgX react with formaldehyde, so what we get? We get first degree primary alcohol and others are byproducts. Okay, now let me show you simple reaction. Let's say in place of alkyl group I have CH3 Mg chloride. So what will the name of this compound? The name of this compound will be the methyl magnesium chloride. So when I react methyl magnesium chloride with formaldehyde, now this is the formula of formaldehyde. In formaldehyde we know that this carbonyl carbon have partial positive charge, oxygen due to its electronegativity has partial negative charge. On the other hand, magnesium has partial positive charge, and due to this magnesium, this group have partial negative charge. Now what will happen? The negative part will going to attack on the positive part. So this part will behave like a nucleophile and it will basically attack on the partial positive carbon. On the other hand, this carbon double bond will going to break, so oxygen will attack on magnesium because oxygen has a partial negative charge, so it will going to attack on positive partial positive magnesium. And you have to remember how I just draw the arrow. Arrow should be drawn in such a way that the tail should be on a negative part and the head should be on the positive part. So what I will get this product. All the atoms on the formaldehyde will be the same, but what thing has added with the carbon CH3 and with the oxygen Mg magnesium chloride is added. Now you can see there is previously it was double bond between carbon and oxygen. Now there is only a single bond. This will be the product in a first stage. So if we hydrolyze this product, if we react this product with water in presence of acidic or basic medium, right now I am using acidic medium. So what I will get, I will get primary alcohol. Now you can see this is called first degree alcohol. And what would be the byproduct? The byproduct would be HOMgCl. That would be the byproduct. So what happens? How we got this product? Basically, when we react it with water, so water break down into two ions, H positive and OH negative. This H positive ion attached with oxygen and this OH negative ion is attached with magnesium, and the bond between oxygen and magnesium break down. So that is the way we are able to get this product. Now let's talk about the second example. In the second example, I will explain what happens when it reacts with acid aldehyde. So what is the formula of acid aldehyde? It is CH3 C double bond O H. So when we react acid aldehyde with Grignard reagent, we get second degree alcohol. Now let's see what happens. Let's say right now I am using ethyl magnesium bromide and we are reacting it with acid aldehyde. This is the formula, structural formula of acid aldehyde. If you just remember that carbon must have partial positive charge due to this electronegative oxygen. On the other hand, magnesium, due to its electropositive nature, it must have partial positive charge, and due to this partial positive or highly electropositive magnesium, this hydrocarbon chain will have partial negative charge. So now this negative part will attack on the partial positive carbon. On the other hand, oxygen will attack on partial positive magnesium. So that is the way we will going to draw the arrows. So initially we will get the product like that. All the atom will be same, but some atom will add because of the double bond. Number one, on the carbon, the alkyl, or I must say here ethyl, will going to add. On a oxygen, magnesium bromide will going to add. Okay, now this will be the initial product. So when we hydrolyze this thing, hydrolyze means react with water in the presence of H plus ion. So what will happen? This will happen that water ionized, positive part will going to attach with oxygen and negative part will going to attach with magnesium. So what product we will get? We will get the alcohol, and this alcohol is second degree alcohol, and we will get the byproduct as HOMGBr. Similarly, if you are able to understand the reaction with formaldehyde as well as acetaldehyde, so then you may also able to understand reaction with ketone. For ketone, I am using acetone, so I am also reacting acetone with the same reactant C2H5 ethyl magnesium bromide, reacting with acetone. What is this acetone? The 2-methyl group is attached with carbonyl carbon. Now, if you just remember how to draw the arrow, this one is partial positive end and this one is partial negative end. So this partial negative part will going to attack on this partial positive, and this one is partial negative and this one is partial positive. So electronegative oxygen will attack on partial positive magnesium. After this, we will basically draw the additive product, that is CH3CCH3. On the carbon, we will going to attach ethyl group C2H5, and with the oxygen we will going to attach magnesium bromide. Now that would be the first product, initial product. So when we hydrolyze means when we react it with water in an acidic medium, so what will happen? The hydrogen will attach with oxygen and magnesium will attach with OH, and we will get the tertiary alcohol. And the byproduct will be the same HOMGBr. Okay, now let's summarize the reactions. So if you just remember, when we reacted it with formaldehyde, we got first degree alcohol, and when it reacted with acetaldehyde, we got second degree alcohol, and when with ketone we got third degree alcohol. So you have to remember that thing. This is very important reactions, that how to prepare first degree, second degree and third degree alcohol by using Grignard reagent. Now moving toward the fourth one. In the fourth one, I will discuss reaction with carbon dioxide. So what happens when Grignard reagent react with carbon dioxide? We get carboxylic acid. So this is also very important reaction. Let me show you the real example. Let's say right now I have methyl magnesium iodide. Okay, when methyl magnesium iodide reacts with carbon dioxide. Okay, now right now I'm just, it is better that we should draw the structure of that compound, then we are able to understand it more. So right now I didn't write just CO2, I just write it down the structure. So first what we will going to do, we will basically mark the positive end. Right now this carbon will have partial positive charge and this oxygen will have partial negative charge. Both the oxygen basically will have partial negative charge. So only the one oxygen will involve, so that is the reason I will focus on the first one. On the other hand, on a Grignard reagent, magnesium will have partial positive because of its electropositivity, and because of its electropositivity the CH3 will have partial negative charge. So what will happen, this partial negative or this negative part will going to attack on the positive part of the reagent of this carbon dioxide, and this oxygen will going to attack on electropositive end of this Grignard reagent, which is magnesium. So what we will get, basically we will get a product in which one carbon double bond will be the same, but here we will going to attach CH3, and here the carbon oxygen bond will break, and here we will get OMGI. Now similarly, if you just remember the last three reactions, we will going to hydrolyze this product in acidic medium. So right now I am using water, I am writing water as HOH, and I am using acidic medium. So then the hydrolysis will occur. So what will happen here, this oxygen will going to attach with hydrogen, and this OH will going to attach with magnesium. Then the bond between this will going to break, and we will get our final product. That our final product will be HOC double bond O CH3. If you just remember, this is also can be written in such a way that CH3 C double bond OH. So we can write this thing as in this way. So if you just remember, this is the formula of acetic acid, which is a carboxylic acid, and what will be the byproduct? I am writing byproduct as IMgOH. So that will be the byproduct. Okay, now I will explain the last part of this lesson, that is the reaction of Grignard reagent with ester. So what we get when we react it with ester, we also get third degree alcohol. So if you just remember that how previously how we got alcohol with the help of ketone. When Grignard reagent reacted with ketones, then we get alcohol. When ester react with Grignard reagent, it initially form in step number 1, it initially form ketone, and in the second step we get third degree alcohol. So this is the way we are able to get third degree alcohol from the ester. Now let me show you how it happens. Now let's say I'm taking ethyl magnesium bromide, and I am reacting it with a common ester, that is ethyl ethanoate. So similarly, first I will going to identify the partial positive and partial negative ends of both the reactants, and after that I will going to draw the arrows. This negative part will going to attack on this carbonyl carbon, and oxygen will attack on magnesium. So first what we will get this product. OMGBr with the carbon OC2H5 will be the same, but the new thing which will going to add, that would be C2H5. Now in the previous reaction we just hydrolyzed them, but this is not the final product in this. So this initial product transform into ketones. So how it transforms, basically because of this group is a very good leaving group. So basically it combined with magnesium bromide, and the carbon and oxygen double bond again forms. So what we get after this, we get the ketone. by the removal of C2H5OMGBr. So they easily removed and we get the ketone. Now the reactant also contain so many molecules of Grignard reagent. So in the second step, what happens? The Grignard reagent react with this ketone and it converts this ketone into third degree alcohol. If you just remember the reaction I already explained, in a similar way this ketone converts into alcohol. And that's all. Thank you.